Okay, so this is sort of day one of limits. There's a lot of information. So we're going to take them kind of in chunks so you can see the things that you're supposed to look for. So this first chunk here is about limits as x or n or whatever your variable is approach infinity or negative infinity. The good thing about these is that we've done them before. So if you kind of think back to our sequences and series unit, we talked about limits as n, in the case of sequences, went to infinity. So this is the same idea. So in general, for a rational function, which is what we're looking at here, you're looking at degree. Okay, so you have to look at the degree. So if it's top heavy, okay, then the y's approach either infinity or negative infinity. If it's bottom heavy, then the y's approach 0. And y's are what the limit is, but they approach 0. And if they're equal in degree, then it's the ratio of the leading coefficients. Now this should all sound familiar because in addition to being something that we did in the sequences and series unit, it's also what you did when you tried to find horizontal asymptotes. So it's the same idea. But here's what I need you to get in the habit of. Okay, when you go to do a limit, your first thing is to always look at this. What is n approaching? Because what you do depends upon that. So in the case of n approaching infinity, that means that what we're looking at is what is the n behavior. Okay, and so since horizontal asymptotes are predictors of n behavior, that's why you see the same idea of top heavy, bottom heavy equal coming up again, but in a different context. So in this case here, I would look at the bottom, look at n approaches infinity, and then I would look at my degrees. So the numerator is degree 2, the denominator is degree 1, and so, oh goodness, so this is a top heavy, or I'm going to circle this. That's how I'm going to know it's top heavy. Okay, so when it's top heavy, the limit is either infinity or negative infinity, and you have to reason through which of those it is. So for instance, in this case, if I were to plug infinity in for n in the numerator and square it, the top would come out positive. And if I were to plug infinity into the bottom and add 1, the bottom would also come out positive. So that's how I know that this limit is positive infinity. Okay, as a side note, let's say instead this limit had said as n approaches infinity of n squared over 1 minus n. So I just changed one thing. You would do the same idea. You would say this is top heavy. If I plug in infinity and square it, the top is positive. But in this case, if you plug infinity into the bottom, 1 minus infinity would be negative. So this limit would actually come out to negative infinity. Okay? Okay, so number 2 here, if you were to, so again, first things first, look at what x or n or whatever your variable is approaching. So x is approaching infinity. That's how I know I'm looking at n behavior. So I care about the degree. In this case, if I were to FOIL this out, the numerator is 4th degree, denominator is 4th degree also. So these are equal in degree, which means I care about the coefficients. So the coefficient of the 4th degree in the denominator here is 2. The coefficient in the top, if I were to FOIL this out, would be 1. So that limit is 1. Okay, same idea here. N approaches infinity. That's how I know I'm looking at n behavior. In this case, this is bottom heavy because the degree in the denominator is 1, but the degree in the numerator is 1/2. And so anytime it's bottom heavy, it's 0. However, you've got to be a little bit careful on these because sometimes these can be does not exist. So for instance, since I have a square root, I can't square root negative numbers. So let's say instead, this the limit as n approaches infinity of negative 2 root n over 3 plus n. But instead of infinity, it was negative infinity. You would do the same thing. You'd say, oh, this is bottom heavy, and you would initially start to say 0. But the problem is here. If I plug in negative infinity here, I'm not allowed to square root that. And so even though by the rules you would say 0, this limit does not exist because there isn't a graph to the left. because you can't square root negative numbers. Okay, why don't you pause the video and try the remaining 3 in this section and then unpause and we'll see what you got. Okay, so in this mustardy yellow color, you'll see the solutions. I've circled where it's either top heavy or bottom heavy. Okay, so you'll look at 4 and 6 are both top heavy, which means the answer should be either infinity or negative infinity. And you have to reason through what that is. So in this case of number 4, if I plug infinity into the top would come out positive, but infinity in the bottom would come out negative, and that's how I knew that one was going to come out negative. And 5 is the tricky one, right? You can't square root, so since x is approaching negative infinity, I can't square root negative numbers, and so this one doesn't exist. Okay, if we switch now to exponential functions, the rules are still basically the same. You're still looking for whether it's top heavy, bottom heavy, or equal, but it's a little bit different. So in this case, the highest base is what you care about. So the highest base is kind of where your heavy goes, or let's say the highest base wins, so to speak. And then the second thing is that an exponential always grows faster than a polynomial. So, sorry, I can't write and talk at the same time. Grows faster than a polynomial. So what that means is that if you have a exponential in the numerator and a polynomial in the denominator, it doesn't matter what the exponent is, it doesn't matter what anything is, the exponential is always going to be where your quote-unquote heavy is. Okay, so let's try this same idea here. Okay, so in the bottom, the biggest base is the base is 2.5, and in the top, the base is 3. The biggest base is 3, so I would circle this as a top heavy. So remember, when it's top heavy, it's either infinity or negative infinity, and you just have to reason through that. So n is approaching infinity. So in the top, if I have 2 to a big power minus 3 to a big power, the top is going to come out negative. And in the bottom, 2.5 to a big power is going to come out positive, and so this should come out to negative infinity. Okay, look over here, n is approaching infinity. That's how I know I care about top heavy, bottom heavy, or equal. This one is actually bottom heavy. This is what I'm talking about an exponential grows faster than a power. So the top is an n cubed, that's a polynomial, and the bottom is an exponential. So it doesn't matter what the exponent is on this polynomial. It could be n to the 30th. An exponential will eventually grow faster. And since n is going to infinity, we have a lot of time in eventually. So this is bottom heavy, and so that would be 0. Okay. All right, case 3, still with n approaching infinity or negative infinity, is other things that are not necessarily a top heavy, bottom heavy situation. And these ones get a little bit tricky. So the biggest advice I can give you is to always, when you're trying to do these, consider the end behavior. Okay, so sometimes that means you have to consider the graph. Sometimes that even means you might sketch the graph if you can. These ones are a little harder because they take a lot of just thinking, and there's not much computation, and so you got to be patient. Okay, so let's try just these couple here. Here we are, n is approaching infinity. Okay, and there's not really a top heavy, bottom heavy here, but I do know that if I plug infinity in, the bottom is going to be a really big number. That's what I do know. Okay, and because of what you should know about cosine, you should know that no matter what number I plug into cosine, all I ever get out of cosine are numbers between -1 and 1. So it doesn't matter. I could take the cosine of, 3 pi halves. I could take the cosine of 16 pi thirds, or even bigger, and I still get numbers that are between -1 and 1. So if you think about that, if I take these numbers and I divide them by a really big number, what happens when we divide by a really big number is we get 0. Okay, now sometimes here we might get what we call a positive 0, so you might get 0.00002 or something, or what I might call -0, which would be 0.000002, but with a negative in front. These two are equally close to 0. So graphically, what would be happening is it would be getting closer to 0, but sometimes it's just above 0, and sometimes it's just below 0. Okay. The second one can be done in a few ways, but again, always look at this first. Okay, so I care about end behavior. So I might do a little bit of rewriting if I were going to do this one. So I might take that negative and put it inside as an exponent using my log properties. And then I might, well, I am, use that negative exponent to flip this, right? So 1 over n to the negative 1 is just the log of n. And then hopefully you have a rough idea of the log graph. So the log graph goes like this. And so the bigger numbers I put in for n, which means as I go to the right on my graph, my y's go up. They go up really slowly, but they go up, which makes this infinity. Okay, so now we're to a new type. Okay, this type is when x is approaching a number. Okay, and so there's a lot of cases here. So the first thing you should always do is you always substitute in the number. Okay, first thing. And then one of three things is going to happen when you do that. So you're either going to get a number. That's the first case that we're going to do right here. Okay, or you're going to get a number over 0, or you're going to get 0 over 0. And depending on which of those three things you get, depends on what you do. So let me just talk you through. If I were doing this number 12 here, the first thing I would do is I would look here at what x is approaching. If x is approaching a number, the very first thing you do is you plug in the number. Okay, so I plug in the number. This becomes 2 times 2 plus 5, and the bottom is 3 times 2 minus 2. So that's 9 over 4. This is a best case scenario. Okay, if you just get a number, that means that on the graph, nothing crazy is happening at x equals 2. It means that if you plug in a 2 and you get out 9/4, then on this graph, let's see, there's just a point right there. Not a hole, not a vertical asymptote, just a point. And then you're done. If you plug in your number and you just get out another number, then you're good. So let's try that same thing here. X is approaching -1. So the very first thing when x is approaching a number is I plug in that number. So I would have -1 minus 7, and then that would be over -1 squared minus 3 times -1. That would give me -8 over 4, which is -2. So if the limit as x approaches -1, sorry, it's taking me a minute, this is equals -2. And again, graphically what that means is there's just a point here. Just a regular old point, whatever this graph looks like. No asymptote, no hole, just a point. Okay. Case number 2 is if when you plug in that number, you end up with a number over 0. Okay. So if you end up with a number over 0, that means you have a vertical asymptote. And if you just think about that graphically, when you have a vertical asymptote, okay, I'm just going to make a random vertical asymptote. As I approach a vertical asymptote, I'm either going straight down or I'm going straight up. So anytime you get a number over 0, that means there's a vertical asymptote, which means your limit has 3 possible answers: infinity, negative infinity, or does not exist. Okay? So again, let me talk you through what I would do. If I'm doing this problem, this says x is approaching 0. That's a number. So the very first thing I would do is I would plug in that number. And I get -4 over 0. Okay, much different than what I got up above. As soon as I get a number over 0, I know that I have a vertical asymptote. Okay, so this is where it gets a little tricky. You have to do quite a bit of thinking, but most importantly, you have to check the left and the right side of that vertical asymptote to see if it's doing the same thing on both sides. This is what I typically do. Okay, the top was a -4, so I just keep that a -4. Okay. Here's my number line. Here's 0. If I approach 0 from the left, then my bottom would be a really small number squared. So let's just call it 0.1. Oh, sorry, -0.1 squared. What you care about is, does this number stay positive? Is it positive or is it negative? That's what you care about. Okay? We don't care about what the actual number is. We're not going to actually square it. We're just saying, when I plug in a number that's really close to 0, but on the left, is it going to come out positive or negative? So if I take negative 0.1 and I square it, this bottom is going to come out to positive. So we call this, or I do anyway, positive 0, which I know is very weird. Okay, what we're saying is that it's getting infinitely close to 0, but it's still positive. That's what we're saying by positive 0. So I have a negative number over a positive 0, so this would come out to negative infinity. And then you check the other side as well. Okay, but as I approach 0 from the right, this would be like 0.1 squared. So I'm going to keep this negative 4, and all I care about is if this comes out to a positive number or a negative number. That's close to 0. We already know the bottom is getting close to 0. I just care if it's close to 0 and positive or close to 0 and negative. And this is going to be positive because I'm squaring. So a negative number over 0, this is going to be not positive infinity, negative infinity. And since these two were the same, then I would say that the limit as x approaches 0 of x minus 4 over x squared is equal to negative infinity. Now look, what that means graphically is that I have an asymptote at 0, and as I get closer to it from the left, the graph goes down, and as I get closer to it from the right, the graph goes down. That's what that means. And you should probably have known that by just seeing that this has a bounce on the asymptote. So when there's a bounce on the asymptote, it should do the same thing on both sides. Okay, so if we switch to number 15 here, whoops, just like this, first thing you notice is that x is approaching a number. So you plug in that number and you get 3 over 0. Okay, so anytime you get 3 over 0, or any number over 0, you know you're going to have a vertical asymptote. And so you have to check both sides of that vertical asymptote, the left and the right. I'm keeping the 3 the same, and I'm just trying to figure out what happens to the bottom. Okay, so if I have my number line here, 2, if I plug in a number that's infinitely close to 2 into the bottom, so let's call it 1.99 minus 2 squared. Now again, I'm not actually computing this number. 1.99 minus 2 will come out negative, but then I'm squaring it. So the bottom is going to come out to a positive number that's super close to 0, so this would be positive infinity. On the right side of 2, maybe it's 2.01. Okay, again, I'm not computing this, but 2.01 minus 2 is a positive number. Squared is also a positive number that's super close to 0. So this is also positive infinity, and since these are the same, the answer to the limit, so the limit as x approaches 2 of x plus 1 over x minus 2 squared is positive infinity. Okay, what this could look like in other instances, sorry, trying to see if there's any other ones, is I'm going to make up one. The limit as x approaches 2, let's just keep this at x minus 2 and x plus 1, so I'm going to remove the squared. Okay, so if you plug in the 2, you still get 3 over 0. Okay, that means there's a vertical asymptote, and I'm going to check the left and the right of my vertical asymptote. Okay, in this case, if I plug in a number to the left of 2, let's say my 1.99 minus 2, 1.99 minus 2 is a negative number that's super close to 0. So this would come out to negative infinity. If I pick a number to the right, 2.01 minus 2, that's a positive number that's super close to 0, and this one comes out to positive infinity. And since these are different, we would say that this limit does not exist. And again, graphically what that means is that I have a vertical asymptote at 2. As I go towards that asymptote from the left, it's going straight down, and when I go to the right, it's going straight up. And since it's not doing the same thing on either side, then the limit does not exist. Okay, and then this is the other option, the other case, okay, is if they're both 0. Okay, if they both equal 0. So first we said you plug in the number, you get a number. Then we said you plug in a number and you get a number over number. Sorry, a number over 0. Now we're going to say you plug it in, oops, and you get 0 over 0. Okay, if you get 0 over 0 in calculus, this is called the indeterminate case. Graphically, it means there's a hole, because there's a factor in the top and a factor in the bottom. And this is where you do algebra. Okay, all the other ones are lots and lots of thinking. This one is just some algebra. Now the algebra can get a little tricky, but it's just algebra. So again, first you look at what x is approaching. If x is approaching a number, you start by plugging in that number. So 2 times 3 minus 6 would be 0. And then this would be 3 squared minus 3 times 3, which is also 0. Okay, that means that you have a whole. And so we do algebra, and there are lots of algebraic tricks that we do. So some of that algebra is to factor. Sometimes that algebra is to get a common denominator. Sometimes that algebra is to use a conjugate. Sometimes it's just to FOIL and combine like terms. You got to get good at knowing which thing to try. Okay. Okay, so the algebra I would try here is I would try factoring. So I'm going to take a 2 out of the top. That'd be 2 times x minus 3, and an x out of the bottom. It's going to be x times x minus 3, and then something cancels. Once a factor cancels, what should happen is you should now be allowed to plug in that 3. So for instance, actually let me rewrite this again. What I have left right now is the limit as x approaches 3 of 2 over x. And now I can plug in a 3 and I get 2/3. Okay, so what happens is once you've removed the whole, then you're allowed to plug in a number. And so now I plug in the number. And so the value of this limit would be 2/3. And what it means is that there's a whole at 3 2/3. Okay, same idea here for this one. If I plug in a 0 first, 4 minus 0 is 4, square root of 4 is 2, so the top comes out to 0 over 0, okay? 0 over 0 means do some algebra, okay? The algebra for this one is called a conjugate, and so let me show you what a conjugate is. The conjugate of this numerator would be 2 plus the square root of 4 minus x, and we're going to multiply by the conjugate on both the top and the bottom, okay? This is my side note here. Conjugates are also, you've seen them more like this, you know, x minus 3, x plus 3. Those are conjugates. What we like about conjugates is that when you FOIL it out, the middle two terms cancel. So what should happen in the top when I FOIL this is that the middle terms will cancel. So let me show you. So this would be the limit as x approaches 0. Okay, so when I FOIL, 2 times 2 would be 4. When I do the outside, I'm going to get 2 root 4 minus x, but when I do the inside, I'm going to get negative 2 root 4 minus x. So those will cancel. And when I do the last, I get minus root 4 minus x times another root 4 minus x is just 4 minus x. Okay, this is the biggest hint I can give you on these, okay? When you choose to do a conjugate, you only FOIL out the two that are conjugates of each other. You do not FOIL out the two that are not. I am not going to FOIL this denominator because this x is my problem. The reason I keep getting a 0 on the bottom is because of that x. So I need that x to cancel. And in order for that x to cancel, I need to have it in factored form. Okay, so I'm going to just clean up my numerator here. This would be the limit as x approaches 0 of 4 minus 4 plus x. So I'm distributing that negative. And then the denominator is x times 2 plus the square root of 4 minus x. In this case, 4 minus 4 cancels. So all I have left in the numerator is an x, which is going to cancel. So what you have now is the limit as x approaches 0 of 1 over 2 plus the square root of 4 minus x. And as soon as you get that problem child to cancel, in this case that x, then what you do is you try plugging in the number again. So if I plug in a 0 now, 4 minus 0 is 4, square root of 4 is 2, 2 plus 2 is 4, so you get 1/4. And that is the value of my limit. That means I have a whole at 0, 1/4. Okay, and then the very last category is just these one-sided limits. And the good thing about them is they're pretty much the same as what we've done before in terms of what you do first, but you just only have to look at it from one side. So for instance, this says as x approaches 3 from the left. Since that's a number, I'm still going to just plug in 3. So I get 2 times 3, which is 6, minus 7 is negative 1. And then I get 3 squared minus 3 times 3, so I get a 0. Okay, this is a vertical asymptote because I get a number over 0. In the previous case, we had to check the left and the right. This means I only have to check the left. So I just care about what's happening on the left side of the asymptote. But the math that you check is the same. Okay, so I know that I have -1, and if I check to the left of 3, so here's 3. Let's say again I have a 2.9. I'm just going to do 2.9 squared minus 3 times 2.9. Now again, I'm not going to compute this. I'm just trying to see if it's going to come out positive or negative. So this is 2.9 times 2.9, and this is 3 times 2.9. So this is bigger. So the bottom is going to come out close to 0, but negative. And so since both of those are negative, this comes out to positive infinity. It's a vertical asymptote. So what happens around a vertical asymptote is always infinity or negative infinity. Okay? And same idea here. This says approaches 1. So I first plug in my number. I get -2/0. That means I have a vertical asymptote. Okay? Once I know I have a vertical asymptote, in this case, I can't read that. Oh, 1 from the left. Okay? So I'm just going to plug in a number that's close to 1 from the left, just really in the bottom. So here's 1 from the left, so 0.9. So this would be 0.9 squared minus 1. So 0.9 squared would come out to be a little bit smaller than 1. And so the bottom is coming out really close to 0, but negative. And since both of those are negative, this would be positive infinity. Why don't you pause the video and try that very last one? Okay, there you have it. So you plug in that 1, you get -2/0. It says 1 from the right, so I'm just checking on the right side of that vertical asymptote. So I've got a vertical asymptote here at 1. I'm just checking what happens as I come in from the right. So if I plug in, I just picked 1.1. 1.1 squared will be bigger than 1. So the bottom will come out really close to 0, but positive. And so I have a negative number over positive 0. So that's negative infinity, which means this graph should be going down as it approaches that asymptote from the right.